This is RD Sharma Solution Class 12, Chapter 7, and we are doing VSAQ, very short answer question, from Chapter number 7, Adjoint and Inverse of a Matrix. Write the adjoint of the matrix A. So there is a shortcut method. I'll just tell you how to do that. But before that, the proper method, the way in which we do this adjoint is by making a cofactor matrix. So when you make a cofactor matrix, this is true for 2 by 2 matrix, 3 by 3 matrix, and so on. So when you write this 3, 4, 7 minus 2, it is minus 3. So I'll just change it. So there are 2 rows and 2 columns here. So we call it as C11, C12, C21, C22. This subscript shows the rows and column. So C11 is minus 1 to the power 1 plus 1. I'll tell you what to write there. Then minus 1 to the power 1 plus 2 for C12. For C21, it's minus 1 to the power, again 1 plus 2 or 2 plus 1. And please remember C22 minus 1 to the power 2 plus 2. What I'm trying to tell you for remembering is minus 1 to the power even is always 1, minus 1 to the power odd is always negative 1. So C11 we are taking C11, that is just hide C11 row and column and write the value, that is minus 2. C12 hide the column and row for C12, 7 will come. And then we have C21 hide the column and row for this C21, you get 4, and leave the column for minus 2 row and column, that is going to be minus 3, that is negative 3. I'll just change it. So negative 3 it is. So this is negative 3. Okay. Now this, as I said, minus 1 to the power odd is going to be negative. Minus 1 to the power even is always positive. So minus 1 to the power 3, minus 1 to the power 3. There are 2 places, so it will be negative. Here it will be positive. It is negative, and this is also positive. Okay. So the sign of C12 and C21 will change. Rest will be same. Minus 2 here. 7 will be negative 7. This is going to be negative 4. And this is going to be negative 3. Okay. So let us write this cofactor matrix. As I said, cofactor matrix, you have to write this as minus 2. In place of C11, in place of C12, replace it by the value minus 7, then minus 4, minus 3. Okay, this is just a cofactor matrix. In order to find out the adjoint, we have to take the transpose, row to column, column to row. So minus 2, minus 7, the row was made as column, minus 4, minus 3 was a row, and we made it as a column. So this is the final answer. Okay, now I'll tell you the shortcut method. Shortcut is negative 3 and negative 2. These diagonal values need to be exchanged in place of, or in case of 2 by 2 matrix. So I'm just doing it directly. Minus 2 here, minus 3 here. So we have exchanged the value of minus 2, minus 3, and 7 and 4. Keep it there, but just change the sign. So minus 7, minus 4. Right? So the same thing has come. These are the ways. Now if A is a square matrix such that A into adjoint A is equal to 5i. So A into adjoint A is equal to 5i, it is given, where I denotes the identity matrix of the same order. That is, again, we are talking about this same order. Then find the value of determinant of A. Okay. So here, we already seen in the exercise, in the properties, when we were discussing theory, we knew that A dot adjoint A is equal to determinant of A multiplied by the identity matrix. Okay. So what is 5 here? If you equate it, the determinant of A is equal to 5 here. Now if A is a square matrix of order 3 such that determinant of A is equal to 5, write the value of determinant of adjoint of A. So in any kind of square matrix, adjoint A, the determinant of this is equal to the determinant of A raised to the power n minus 1. So adjoint A, we have to find out. The determinant of A is already given to us, which is 5. And what is the order? That is going to be 3. So in place of n, you will replace it by 3. 3 minus 1 is 2. So 5 square. That is going to be 25. Now if A is a square matrix of order 3 such that adjoint of A, determinant of adjoint of A is 64, find the determinant of A. So again we have the the property and the relationship adjoint of A, determinant of adjoint of A is equal to determinant of A raised to the power n minus 1. This is 64 given already, and this is determinant of A, n is 3, so 3 minus 1 is 2. Okay. So we get determinant of A square is 64. You can write 64 as 8 square. 8 square is determinant of A whole square. That is simply equal to x square. You can write that determinant of A is equal to plus minus 8. It can be plus 8, it can be minus 8. If A is a non-singular square matrix such that determinant of A is equal to 10, find the determinant of A inverse. So all the properties we have already discussed in the theory. So I'll just give you this determinant of A when it is not equal to 0. Then what we will do? Determinant of A inverse is nothing but is equal to 1 by determinant of A. This we have to find out, 1 by determinant of A. So this is 1 by 10, and that is the answer. If A, B, C are 3 non-null square matrices of the same order. Non-null means matrix with all 0 values. These are of same order. Write the condition on A such that AB equals AC implies B equals C. So that means you are able to eliminate A. Then only B and C will come. You can cancel out A. How that is possible? I'll just show you how it is possible. See. So this is AB equals AC. Now both the sides will be multiplied by A inverse. I'll tell you what is the condition, but first let us multiply by A inverse. This A inverse A is going to be identity matrix, even A into A inverse, A inverse into A is going to be identity matrix. So this is identity matrix. So identity matrix into B equals identity matrix into C, that is anything multiplied by the identity matrix is going to be the same matrix. So B equals C. Now for that A inverse should exist. And what is the condition for A inverse to exist? When it is invertible. That is determinant of A is not equal to 0. That is the actual scenario here. Okay. So determinant of A should not be equal to 0. If A is a non-singular square matrix such that A inverse equals this value, then find the A transpose and inverse. Now non-singular is determinant of A is not equal to 0. So A transpose inverse is equal to A inverse transpose. So A, you take the transpose, take the inverse, and that is equal to A inverse, and then we have the transpose. So they both are same thing, right? So A transpose, we already know that A inverse is already given here. So A inverse is given here, so we can just take this value and we can take the, so I'm just transposing it. So 5, 3 minus 2 minus 1, A inverse transpose, A transpose inverse is this answer. Now adjoint A is equal to adjoint B. No, adjoint A and adjoint B is given. We have to find out adjoint of AB. So adjoint of AB, the expression is like this. Adjoint of AB is nothing but, see, adjoint of B. Please remember this. Adjoint of B multiplied by adjoint of A. So B will come first and then comes the adjoint of A. Okay. So adjoint of B is given 1 minus 2 minus 3, 1. Adjoint of A is 2, 3, 4 minus 1. So let us multiply this. 1 into 2 minus 4 to the 8. It's not 6, it's 8. I'll just change it. Now 3 and minus plus 2. So this already done. First row with both the columns. And now the second row with both the columns. So minus 3 into 2 plus 4 into 1. Next one is minus 3 into 3 plus 1 into minus 1. Okay, what do you get? Here you get 2 minus 8. I'll just change it. It is going to be minus 6. So minus 6, 5 minus 2 minus 10. That is going to be your final answer, right? So this, as I said, I'll just change it. It's minus 6. This is your final. But please remember, it's adjoint AB is adjoint B into adjoint A. If A is a symmetric matrix, write whether A transpose is symmetric or skew symmetric. So A is symmetric matrix. Symmetric means A transpose is equal to A. So when A transpose is equal to A, then A transpose is also symmetric. Because skew symmetric simply means A transpose is equal to negative A. That is not the case here. So A transpose is A for any symmetric matrix. A transpose equals to A. So by this definition, A transpose is also symmetric. Otherwise, if it is negative A, it will become the skew symmetric, which is not the case here, right? So see it here, it's symmetric only. A transpose is equal to A. If A is a square matrix of order 3 such that determinant of A is equal to 2, then write the value of adjoint of A. Again, we have a relationship here. Again, we have an inequality here, equation here. So in any square matrix, the determinant of A, we are interested in adjoint of A. That is, first we have to find out the adjoint of A, then we have to find the adjoint of that resultant matrix. So adjoint of A is simply determinant of A and then to the power of n minus 2, and then we have A here. This is the relationship you have to follow, okay? So what do you get? So determinant of A is already given as 2, raised to the power n minus 2, n is your 3, so 3 minus 2 is 1. So 2 twice of A, that will be the answer. If A is a square matrix of order 3 such that determinant of A is 3, then write the value of adjoint of A. So we have just seen this is adjoint of A. So this is adjoint of A we just saw. But the question is asking about adjoint of A determinant. So it has another relationship which I am going to tell you just now. It's adjoint of A. When we find the determinant, it's going to be determinant of A to the power of n minus 2 into A. But here we have the determinant of this. So when you have the determinant of this, adjoint of A, determinant of this is determinant of A raised to the power n minus 1 whole square. I hope you got the idea. So that determinant of A to the power n minus 1 whole square. What is determinant of A? It's 3. What is n? 3. 3 minus 1 is? That is going to be 2. So 2 square it is. So determine this 3 to the power 4. 3 into 3, 3 into 3, that is 9 9s are 81. 81 will be your answer. Okay. Okay. This question we are going to take in the next discussion. Then thank you so much. Take care of yourself.